Welcome, Algebra 2 students, to the homework help video. Pages 234, 240, and 249. Let's go ahead and jump into this right away. And I think I have the wrong textbook here, so give me about 10 seconds to make sure I get on the right page so that I can check answers as we go along and make sure everything is accurate. Okay, there we go. Alright, let's go ahead and get started with the first problem. Alright, the directions for 27 and 28 say, find the time it takes an object to hit the ground when it is dropped from a height of s. Now, first of all, understand it says an object is being dropped, okay? And in your notes, we have gone over a formula to help you with time and height when an object is dropped. Now, remember, the formula is h equals negative 16 t squared plus s. Now, s is your initial height, or we call it the starting height. So when the problem starts, where's the object at? Is it 10 feet in the air, 100 feet in the air, 5 feet in the air? S is your starting height, okay? Now, h is your terminal height or ending height. In other words, when the problem's all over, where's the object at? If it's laying on the ground, then your height would be 0. If it's caught in your hand 3 feet off the ground, then the ending height would be 3 because it's 3 feet off the ground, okay? And of course, t is your time. Now, please don't forget, if you're going to use this model, your time must always be in seconds. Please don't forget that, okay? And your height, whether it be the starting height or the ending height, your height must be in feet, okay? So if it's not in feet, you've got to convert it over to feet, okay? So please don't forget all that, okay? Alright, you've already learned that, but I just want to go over that again. So here we go. Let's jump into this problem right away. Now, the problem says you have an s, or a starting height, of 25. So for s, I'm going to put 25. Do you see that right here? In the directions, it says, how long will it take for the object to hit the ground? That means at the end of the problem, your object's laying on the ground, so your ending height is 0. So now we go ahead and we solve for t. Well, guys, right away you should notice you have a quadratic equation, right? You have a variable with a power of 2, and there's no higher exponents, okay? Notice there's no t term or no b term, so we can use the square root method, bring the 25 over, and make it a negative 25. Divide both sides by negative 16, and you'll get this. Now watch carefully what happens. These cancel, leaving you with t. A negative over negative is a positive 25 over 16. Now, take the square root of both sides. The square root of t squared is t. The square root of this would be plus minus. The square root of 25 is 5. And the square root of 16 is 4. Now, always put in the plus minus. Don't forget, and then check it in the end and ask yourself, do I need the plus minus or positive negative? You do not need the negative because we're dealing with time. And time cannot be negative, okay? So there's your answer. 5/4 seconds, or 1 1/4, or 1.25. Okay? 28. Exact same problem. We're dropping an object from 64 feet off the ground. It's going to hit the ground, okay? So here we go. H equals negative 16 t squared plus s. My starting height is 64. My ending height is 0. And I'm looking for time. So here we go. Let's solve for t. Bring the 64 over and make it a negative 64. Divide both sides by a negative 16. Negative 64 divided by negative 16 is a positive 64 over 16. Now normally I would reduce that, but I'm not going to because I notice in a second I'm going to take the square root of both sides. 64 is a perfect square. 16 is a perfect square. So I can take the square root of both of those numbers. So I'm going to leave it like this. Now if you reduced that and you put 32 over 8, and then you took the square root of that, you'll get the exact same decimal answer right here that I'm going to get. You will get 2. In fact, this could be reduced even more to 4 over 1, which is 4, and the square root of 4 is 2. So either way, you'll get the same answer from me. I'm going to leave it just like this. Okay? I'm going to take the square root of the right side, which would be t. Take the square root of this side. The square root of 64 is 8. The square root of 16 is 4. Normally you would put positive, negative, but in this case, we're dealing with time, and time cannot be negative. Now you can reduce that. 8 over 4 is 2. Excuse me. So the time that would take for this object to hit the ground would be 2 seconds. I want to talk to you about something, a problem that would be a very fair problem on a quiz or a test. What if this problem said an object is dropped 64 feet off the ground and a person catches it 5 feet off the ground? How long would it take? Well, the initial or the starting height would be 64. However, the ending height would be 5 because you cut it 5 feet off the ground. Do you see what I'm saying? Whenever the object hits the ground, then your ending height is 0. However, if I said the object is cut 5 feet off the ground, then we would set the problem up like this. Okay? Bring the 64 over, make it a negative 64. You would get negative 59 equals negative 16t squared. I'm not going to work this out, but you would divide both sides by negative 16 and take the square root of both sides. Okay, but understand that's a very fair problem. Okay, so understand S is the, or excuse me, H is the ending height. Okay, alright, moving on. Number 29. The height of a falling object on Mars after t seconds is given by this model here. So obviously with the difference in gravity and all of that, it's going to be a different formula than the one we use on Earth. Okay, the one we use on Earth would be, of course, the one we just looked at. H equals negative 16t squared plus s. Okay? So here we go. We're on the planet Mars, so we're going to use this formula here. Alright? One of the rocks scooped up by the Viking 1 space probe fell back to Mars' surface from a height of 72 feet. How long would it take the rock to hit the ground or reach the surface? Okay, my ending height, H, would be 0. Because at the end of the problem, the object is laying on the ground. We're looking for time, so I'm going to leave t alone. S is your starting height. Well, it started from a height of 72 feet. There we go. Let's solve the problem. Bring the 72 over, make it a negative 72. Divide both sides by a negative 6. Negative 72 divided by negative 6 is 12. Now take the square root of both sides. The square root of 12, let me grab my calculator real quick. The square root of 12 would be 3.464. I'm going to put 3.5. So the square root of 12 is 3.5. The square root of t squared is t. You're used to putting positive, negative. We're not going to worry about that because we're dealing with seconds. The seconds would be positive. So the answer is the rock would be in the air for 3.5 seconds. Okay? 3.5 seconds. Alright, moving on to number 30. Now, number 30, we're still continuing on with the same problem, but now we're going to pretend the rock was on Earth. So this is the model you would use here if you dropped an object on Mars. The model you would use for here on Earth would be, well, you guys already know it, H equals negative 16t squared plus s. Okay? So the same rock was dropped from the same height. How long would it take to reach the surface? So at the end of the problem, the rock is laying on the ground, so 0 goes in for H. T is what I'm looking for, the time. My initial or starting height 70, what was the height? I forget. 72. Alright, bring the 72 over, make it a negative 72. Let's divide both sides by negative 16. So, negative divided by a negative is positive. 72 over 16 will reduce to 9 over 2. Now, you don't have to reduce it, okay? You're going to get a decimal answer anyways. You could have left it as 72 over 16 if you wanted to, okay? But 72 over 16 reduces to 9 halves. Now, I'm going to take the square root of both sides. The square root of 9 halves would be 2.12. And the square root of t squared is t. So there we go. The rock would be in the air for 2.1 seconds. 2.1 seconds. Okay. Moving on, number 33, number 31. At sea, the distance in miles that you can see to the horizon depends on your height. If your eyes are h feet above sea level, then the approximate distance you can see is given by this model right here. Notice your d is in miles, and your h is in feet. So this is a really cool model, okay? You tell me how many feet above sea level you are. Or your eyes, if you can tell me how high above sea level your eyes are, I can tell you how far out to sea that you can see. Or the opposite's also true. If you tell me how far out you can see, I can tell you how tall you are, or at least how tall you are up to your eyes. Okay, so pretty cool model here. So here's what we're going to do. First of all, they want us to solve for d. Now we know how to do that, okay? We've learned how to solve multivariable equations. That was back in chapter 1. So here we go. D squared equals 3 over 2h. We're going to solve for d. To get d by itself, we're going to take the square root of one side. However, if you take the square root of one side, you must take the square root of the other side. Now, the square root of d squared is d, and over here you're used to putting a positive negative. Don't do that because we're dealing with distance and height. And distance and height cannot be negative, okay? So, we would not put positive negative. But this 3 halves h, the entire thing would be under the square root. Now, I know that I'm finished. I know that I solved for d because d's all by itself, okay? So step 1 is done. Solve this equation for d. Now next, a 6-foot person is standing on the seashore. How far out to sea can the person see? Now, to be honest with you, this is not a very well written problem because it says up here specifically your eyes are a certain distance above sea level. But here it says the person is 6 foot tall. So if they're 6 foot tall, you've got to guess how many inches to take off, and we're not going to do that, obviously. They meant for you to use 6 feet, but I'm just saying it's a little off there. They should have said the person's eyes are 6 feet above the seashore. But anyways, if you're standing on the seashore, then you're right at sea level. Does that make sense? If you're standing on the seashore, okay, then you're standing right at sea level, okay? So you're standing at sea level. You're 6 feet above sea level. How far out can you see? Well, h is how many feet above sea level you are. D is your distance. We're looking for the distance. How far out can you see? If you're 6 foot tall, so where the h is right here, I'm going to put a 6. So my distance I can see out across the sea would be the square root of 3 halves times 6. Now, the square 3 over 2 times 6 gives you 9. So now you have the square root of 9, okay? And the square root of 9 is 3. Now don't forget d is in miles. So your answer is 3 miles. So if you're 6 feet tall, or if your eyes are 6 feet above sea level, then you can see 3 miles out on the sea. Okay? Alright, moving on to number 32. The period of a pendulum is the time the pendulum let's say it starts right here and it swings here and then back. Well, the time that it took to go from here to here and back again is called 1 period. Or, to be honest with you, you could also say, if your pendulum's here, it's the time that it takes for it to swing here, back to here, and then back to where it started. Either way, it's one full rotation this way and back again. The time that it takes to do that is called 1 period. Now, the period t in seconds is modeled by this, where the length of the pendulum is t. It's got to be in inches. Let's label that real quick. T's got to be in inches, and t's got to be in seconds. Okay, now, so the longer the pendulum or the shorter the pendulum influences the period of the time of the period, how long it takes the pendulum to go from here to here and back again. Alright, so the longest pendulum in the world is in Tokyo, Japan. It's part of a clock on a building. It's 74 feet long, but remember, you've got to use inches on this length, okay? So 74 feet is the same thing as 888 inches. What is the period of this pendulum? Okay, no problem. I'm looking for time. Remember, the period of the pendulum is the time it takes to go back and forth. So I'm going to find how long it takes, alright, for this pendulum to swing there and back by putting in 888 for D. D stands for the length of the pendulum is T. So 888 equals 9.78 T squared. Alright, now let's divide both sides by 9.78, and if we do that correctly, we're going to get 89.96960486. I'm going to go to round that to 90, okay? Now take the square root of both sides, and you're going to get 9.48. I'm going to put 9.5. So it's going to take the pendulum 9.5 seconds to go from to swing to here and then to swing back again. It's going to take about 9.5 seconds approximately. Okay. Alright, moving on to number 33. From 1970 to 1990, for 20 years, the prize money P in dollars at the Professional Golf Association Championship can be modeled by this model here. Now look, P equals 2875 T squared plus 2,000. Now watch, or 200,000. Now, P is the prize money in dollars. Don't forget that. So this is the money in dollars. Okay. T is the year. Okay, so T equals 0 represents 1970. So T is your time in years. Alright. So here we go. During which year was the prize money first over 1,350,000? Now, you've got two variables here, guys. You've got a P that stands for prize dollars, and you've got a T that stands for time in years. What are they giving you here? Are they giving you the prize money amount or the time? They're giving you the prize money amount. So why would that go in for T? It wouldn't, would it? It would go in for P. Another way to look at it is this. It says, during which year? Well, that means I'm looking for T because T is the time in years. So I'm solving for T. So I'm not going to put anything in for T. I'm solving for T. I already understand that the prize money they want me to find out the time frame for is 1,350,000. Okay, students, now I've made my substitutions. I'm solving for T. Notice you have a T squared, a quadratic equation. There's no T sides by 2,875, and you will get this exactly. 400 equals t squared. 400. Now, in order to get t squared by itself, we have to take the square root of both sides. Now, the square root of 400 would be 20. 20 times 20 is 400. And the square root of t squared is t. Now, your answer is not 20. Let me say that again. Your answer is not 20. It says during which year was the prize money first over this. So, t equals 0 corresponds to what year? 1970. So 0 goes with 1970. So 20 years later, 20 would go with what year? 1990. 10. If I got 10 out for x, that would go with 1980. If I got 8 out for x, my answer would have been 1978. If I would have gotten 16 out for x, then my answer would have been 1986. Okay, so 20 equals x or t, my fault, t. So if 20 equals t and 0 is 1970, then 20 goes with 1990. So what year was the prize money first over this amount? 1990. Alright, moving on to number 34. Same thing again, guys, exact same type of problem, so pay attention. Let's get these nailed down, okay? The model I'm going to use is P equals 9400 t squared plus or positive 525,000. Now, notice P is your profit in dollars. Time is your t equals 0 represents 1980, so I know t is my time in years. Okay, so here we go. According to this model, when, that means what time, what year, when would the company have a profit of 2,640,000? Well, guys, they're giving you a value for the profit, so plug that in or substitute that in for P. So for P, I'm going to put 2,640,000, okay? Equals all of this here, 9,400 t squared plus 525,000. Alright, there we go. Now let's get t squared by itself. Notice you have a quadratic equation. There's no t term anywhere. There's no t right here. There's no t term or a b term, whatever you want to call it. So we can use the square root method. So I'm going to take the 525,000 and bring it over here and make it negative 525,000. Alright, so if you subtract those two numbers, you're going to get 2,115,000 equals 9,400 t squared. Now divide both sides by 9,400 and you're going to get 225 exactly. 225 equals t squared. Now we're going to take the square root of both sides. Alright, and the square root of 225 is 15, and the square root of t squared is t. So if t equals 0 represents 1980, so 0 represents 1980, then 15 would have to represent 1995. So in 1995, that's when the company will have a profit of 2,640,000. Okay. All right. Moving on to number 41 on page 240. Okay, guys. Now we learned in our notes from the word problem lesson that there is a formula that helps you find the area of a certain segment of the parabola. Remember, if you have a parabola, and I said to find the area underneath this horizontal line, there's a formula you can use. Okay, and here's that formula. Area equals 2/3 times the base times the height. Okay, so we come over here. The map below shows the country of Mongolia. Each tick mark on the coordinate system represents 60 miles. Use the map to estimate the area of Mongolia. Now, I'll be honest with you, this is a pretty good estimation. Like this little chunk here that sticks out the parabola, that would probably fit in. That'd probably fit in really well about right here. And this whole chunk right here that sticks out would probably fill up this area here pretty good. And actually maybe a tad more. This here would fill this up with just a little bit more left over. And so on and so forth. This would probably fill this up. So it's not perfect, but it's a very nice estimation of the area of Mongolia. So we can do this by superimposing a parabola on top of it and then find the area. See how cool that is? It's really helpful. So in order to find the area of the parabola from here down like this, we're going to use this formula right here. Now, every tick mark is 60. The first thing I need to know to find the area of this parabola or Mongolia, however you want to look at it, is I have to find the base first. Well, the base is the length of this line right here going across. Okay? Now, it starts here. And every tick mark is 60 miles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all the way across I have a length of 24. But each tick mark is worth 60. So 24 times 60 is going to be 1,440. So my base will be 1,440. Go for that again. From here all the way to here is 24 tick marks. Each tick mark is 60. So 24 times 60 would give me 1,440. Now, let's find the base, okay? Or excuse me, the height of this parabola. So the height from here, where the base is, to the bottom would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, each tick mark is 60, so 10 times 60 is 600, so my height would be approximately 600. Alright, so now I'm going to simply take 2/3 times 1440 times 600, and if you do that correctly, let me grab my calculator here, you're going to get, see, 2/3 times 1440 times 600, you get 576,000 square miles. It is area, so don't forget to put the square miles. There we go, 576,000 square miles. Now number 41 is identical to this, pretty much the same problem, okay? And here it is. We're going to find the area of that lake. Using this shape that looks like a parabola, okay? So we're going to find the area of, there's the parabola, see the blue line that comes down, comes back up, so we're going to basically find this area here, which will be very close to the area of the lake beneath Grand Haven in Milwaukee, okay, beneath that. And so here we go. If we're going to find the area of a certain region instead of a parabola, the formula we're going to use is A equals 2/3 B times H, okay? Now here we go. The base of this parabola, and by the way, notice in the word problem, each tick mark is 12.5 miles. So the base goes across from here to here. So we're looking at right there to right there. Here we go. We'd have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 tick marks going across, but don't forget, guys, each tick mark is 12.5 miles. We have to take 8 times 12.5 to get the total number of miles. Alright, so 8 times 12.5 is going to give you 100. So my base is 100 miles. Now my height would start here to be 1, 2, 3, 4, 5, 6, 8, 9, 10. Well, 10 times 12.5 would be 125. So I'm taking 2/3 times 100 times 125. So here we go. 100 times 125. 27 through 30. 27 through 30. All right. Okay, here we go. On the sidewalk, the walk from the high school to the junior high school is 400 meters. So on the sidewalk, from here to here, and then here to here is 400 meters. Okay. By cutting across the lawn, though, which you're probably not supposed to do, but cutting across the lawn is a little shorter. It's 300 meters. How long is each part of the L-shaped sidewalk? They want to know how long the length is from here to here, and then how long is it from here to here. Now, I don't like how this book gives you guys a lot of information. For example, on a test or a quiz, I would not have given this to you right here. So you better listen to me and figure out how to find these. I would not have given you this, or this, or this right here. Okay, so I'm just trying to tell you, listen how you would solve this, okay? All that you know is the total length from here to here is 400. You go down and then over. So, we don't need to know the length of both of these. Just watch this, okay? Now, please watch carefully how I do this. Please, students, watch. I'm going to call this length here x. I'm going to call this length here y. So I know that x plus y equals what? 400. Do you see that okay? Now, by bringing the x over, okay, I now have y equals 400 minus what? X. Do you see that? Positive x. See that? Bring it over and it becomes negative x. Why would I do that? Because now what is y equal? 400 minus x. So what can I put for y right here? 400 minus x. Now that helps because this length here is written with a what? X. And this length here is written with a what? X. Now yes, I know what you're thinking, Mr. Earhart. They have a backward. Backwards they call this x. That doesn't matter. And this 400 minus x, it doesn't matter. Does not matter one bit. I'm just trying to show you where they got this from, okay? We could have called this y, could have called this x, and then for y we substitute right here, 400 minus x. But you better understand where they got this from, because on a test or a quiz, there's a very good chance I'm not giving that to you. Call one of your lengths x, one of your lengths y, add them together, they equal 400, then solve for y. And now we have an expression with x and x, okay? Now, I've got to solve for x now. I've got my nice problem set up here. This is x, this is in terms of x, this is in terms of x, this is a number. Well, guys, you should see right away what to do. You've got a right triangle. You have a right triangle that looks like this. If you're up in the air looking down at it, here's your hypotenuse. This is x. This is 400 minus x. Students, can you not set up a formula for that? Sure you could. Most definitely you could set up a formula for that. Oh, it's Pythagorean theorem, guys. I said formula, sorry. You can set up an equation. Take this leg right here and square it. Take this leg right here and square it. Take your hypotenuse and square it. And now solve for x. See how easy that is? Well, x squared is x squared. 400 minus x, be careful. 400 minus x squared means to write 400 minus x times 400 minus x. 400 times 400 is 16. 16 with 4 zeros. 400 times negative x is negative 400x. Negative x times 400 is negative 400x. Negative times negative is positive x squared. Okay. 400 times 400, 160,000. 400 times negative x. Negative 400x. Then negative x times 400, negative 400x. Negative times negative, positive x squared. So this whole expression right here equals this right here. Okay. So I'm going to pick this up right here and put that in right there and simply make this a positive sign here. There we go. Alright, equals, and then we'll put 9 million. There we go. Now guys, you should recognize right away this is a quadratic formula. Excuse me, a quadratic equation. Right? Sure it is. We've got a quadratic equation here. Do you see that? I've got a power of 2, and that's the highest power I have. That's a quadratic equation. So you cannot solve this by using the square root method like we did for all these other past problems. Can't do it because you have an x term right here or a b term. So let's just simplify everything and see what happens. X squared plus x squared is 2x squared. Okay. Next we'll put our b term next. Negative, cross off these or put a check mark above them. Negative 400, so negative 800x. Then bring down your 1600 or 660,000. And then bring down your 9 million. Now look guys, the only way we've learned to solve this quadratic equation is completing the square, or excuse me, quadratic formula. I think we can all agree that neither one of those two methods are our favorite, but the worst is completing the square. So if I'm going to use the quadratic formula, I better get one side equal to 0. So bring your 9 million over and make your 9 million negative. Okay? So bring it over and make it negative 9 million. Or would it be 90,000? I've been saying. It was 300 times 300, wasn't it? Okay, that's fine. At least we caught our mistake before we got too far into the problem. So it would be 90. It'd be 4 zeros. 90,000. You guys probably already knew that, so no big deal. 90,000. Okay. Sorry about that. So bring the 90,000 over, make it a negative 90,000. That will leave you with a positive 70,000. Now, you are all ready to use the quadratic formula, but why would you want to do that when you can reduce your equation? You can divide everything by 2 and make the number smaller. So divide 2x squared by 2. Divide 800 by 2. Divide 70,000 by 2. And you're left with this right here. Now we're ready for the quadratic formula. Okay? So we have one side equal to 0. We've reduced our equation. Now we're ready for the quadratic formula. So a equals 1. B equals 400, negative 400. And C equals 35,000. The formula is negative b plus minus the square root of b squared minus 4ac all over 2a. Let me copy that so I'll have that for future problems. And here we go. Negative negative b. B's already negative, so we have a negative 400. That's a positive 400. Positive negative square root of b squared. B's negative 400. Negative 400 times negative 400 is 16,000. Or 160,000. And then negative 4. And then we have a times c. A times c. 1 times 35,000. 35,000. All over 2 times a. A is 1, so 2 times 1 is 2. Alright, next. Now, we have 400. Positive negative the square root of 20,000. Okay, because 160,000, if you first take 4 times 135,000, you'll get 140,000. So negative 4 times 35,000 is negative 140,000. So 160 minus 140,000 would give you 20,000. Now, the square root of 20,000 is, let's see, if you type the square root of 20,000 to your calculator, you're going to get 40 plus minus 141. Now I rounded that, so 141 over 2. Alright? So, we're going to take 400 plus 141, and that's going to give us 541, and then divide that by 2, and you're going to get 271. Now, take 400 divided by 2 would be 129.5 or 130. So we're getting out two answers for x. That's okay. They're both positive, so we could use either one of those two. Okay? So here we go. Let's see, ready to solve our work here. If you need that work, just back up the video and pull it down. Now, here's the final question. They want to know the lengths of each of these, and actually, how long is each part of the L-shaped sidewalk? So here we go. So if we put this in, let's start with this answer first. I'm saying now what's going to happen, which is fine. So either one of these two answers for x is acceptable. Please don't zone out, students. Don't miss this, okay? We just solved the equation for x. That's not our final answer. They want to know how long is each part. So this part here is 400 minus x. So pick one of these answers. It doesn't matter which one. Pick one of them. Okay, I'm going to pick this one, okay? So put 271 in for x. 400 minus 271 is going to give you 129. So if I put 271 right here, 400 minus 271 is 129. And then for x right here, I'm going to put 271. So there's my dimensions. One sidewalk is 129, the other sidewalk is 271. Okay, now let's choose the other answer. Now let's use this for x. And you got the exact same answer, so it doesn't matter. Watch. I'm going to put 130 in for x right here. Well, 400 minus 130 is 170, or 270, which is close enough to 271. That's fine. And then for x right here, I would put 130. So the other answer would be 130 by 270. They're identical. They were just rounded in different places. So the lengths of the two sidewalks are 130 or 129 by 270, 271, around in there. Okay? Those are the lengths of the two sidewalks. But anytime you get out two answers from your quadratic equation, try to use both of them if you can. Now sometimes you can't. For example, if this would have been negative right here, then you know you can't use that, because when you come up here for x and put negative 271, you'd have a negative distance or a negative length. You can never have a negative length, but always try to use both of your answers. You don't want to leave any possible answers out. All right, number 28. Your home is built on a square lot. Now, on the last problem, I said if we call this x, we're going to call this y. I had to use two different variables, x and y, because they're two different lengths. Okay? On this problem, your house is built on a square lot. Well, a square has the same lengths all the way around. So you can call this side here x, and you can also call this side x, because they have the same length. Okay, moving on. Your home is built on a square lot. To add more space to your yard, you purchase an additional 4 feet along the side of the property. So you buy this extra little piece of land here. The area of the lot is now 9,600 square feet. So this entire lot, the whole area is 9,600 square feet. What are the dimensions of the new lot? Now, let's think this through. We got to come up with an equation in which we can solve for x. Well, ask yourself, what kind of information have they given you? Well, they've given you the area, correct? Well, the area of this entire rectangle is 9,600 square feet. We'll hold it. What's the length of this side here? X. What's the length of this whole side right here? 4 plus x, right? From here to here is 4, and from here to here's x. Add those two together. 4 plus x is the length of this whole side. So if I take one side, which is 4 plus x, times the other side, which is x, that should give me 9,600, right? Anytime you have a rectangle and you take the length times the width, you'll get the entire area. And so that's what I'm doing. this is my length right here. This is my width. Length times width equals my area, 9600. So here we go. 4 plus x times x. Take your x and multiply it through. X times x is x squared. X times 4 is 4x equals 9600. So I have a quadratic equation. I know that because I have a power of 2 for my variable, and there's no higher exponent. So the only way I can solve this, I cannot use the square root method because I have an x term right here, or a b term, whatever you want to call it. Okay, I've got an x term here. So I know that I can't use the square root method, so I have to use completing the square or the quadratic formula. Obviously, the quadratic formula would be a lot easier to use. Okay, so I'm going to use the quadratic formula to solve this problem. Alright? And so here we go. First of all, you guys know you cannot use the quadratic formula unless one side is equal to 0. Never use the quadratic formula unless one side is equal to 0. So I'm going to bring the positive 9600 over and make it a negative 9600. There's my formula. Alright, so a equals 1, a equals 1, b equals 4, and c equals negative 9600. So negative b is 4, negative 4, positive negative or plus minus the square root of b squared, b is 4, so 16, then negative 4 ac, so a, which is 1, times c, negative 9600, all over 2a, a is 1, so 2 times 1 is 2. Now, if you simplify under the radical, you're going to get this. You're going to get 38,416. 38,416. Now here's how I got that. Negative 4 times negative 9,600 is going to give you 38,400. Okay? So a negative times a negative is positive. Positive 38,400 plus 16 gives you 38,416. Now, believe it or not, this number right here is a perfect square. So when you take the square root of 38,416, you're going to get exactly 196. 196 times 196 gives you 38,416. Now let's continue on up here. I have negative 4 plus 196 divided by 2, and I have negative 4 minus 196 divided by 2. Alright, now here I'm going to get 192 over 2, that's going to be 96. Over here I'm going to get negative 200 divided by 2, negative 100. So there's my two x values. X equals these two numbers right here. Alright, now let's see how all of that applies to the problem here. Okay. What are the dimensions of the new lot? No, look, one side is x. So there's no way I can put negative 100 in for x right here. I can't do it. You can't have a length of negative 100. So I know for sure that this answer here is not going to help me. But 96 will help me. For x right here, I'm going to put what? 96. And don't forget the length of this whole side was what? 4 plus x. 4 plus x. X is 96. 4 plus 96 is, right here for x, we're going to put 96. 4 plus 96 is 100. So the length of the property from here all the way over to here is going to be 100. And guys, that totally makes sense because 100 times 96 gives you an area of 9,600. Okay, so it does make sense. Alright, number 29. A windlass is used to pull a boat to the dock. The rope is attached to the boat at a point 15 feet above the level of the windlass. Find the distance from the is 75 feet, so we gotta find the distance from the boat to the dock when the length of the rope right here is 75 feet. Well, guys, this is nothing more than geometry from last year. You have a right triangle right here. And we're just finding the missing length of one side right here. That's all that we're missing. Alright. So I'm going to go ahead and draw that triangle on a little smaller scale over here. The height here is 15. The length of the hypotenuse or the rope is 75. And we're looking for this length right here. So square one of your legs, that's 15. Square one of your other legs, that's x squared. Square your hypotenuse. Now 15 squared is going to give you 225. X squared, of course, just stays x squared. 75 squared is going to give you 5,625. Now we have a quadratic equation in which we do not have an x term or a b term. We do not. Okay? So because of that, we can definitely use the square root method. So let's go ahead and bring the 225 over and make it a negative 225. Alright? And that's going to give us 5,400. And now let's take the square root of 5,400 and we're going to get 73. We'll take the square root of x squared as x, and the square root of 5,400 would be 73.48 or 73.5. Now, that would be in feet. Everything's in feet. So if the rope is 75 feet long, this distance from here over to here, right here, that distance is going to be 73.5 feet. 73.5 feet. Okay? Alright, one more problem. Now, students, before we start this problem, I want to say to you on a test or a quiz, I would not give you this here. I would not give you this here. I don't like how they've done this, guys. It's making it way too easy. They're taking away the more challenging part of the math, which is finding it, which is being able to use algebra and find these lengths, okay? Alright, here we go. Now, you have 200 feet of fencing to enclose two adjacent rectangles. So this is a rectangle here. This is a rectangle here. You're going to enclose them, okay? Now, the total area of this enclosed region is 1,400 feet. So this whole area is 1,400 feet. Now, we're going to find the dimensions of each corral. So having said that, students, take good notes and listen to me carefully. Now, I don't care what you call this length right here. I'm going to call it x. If this is x, we know this is x also because it says the corrals are the same size. So if I call this x for this rectangle here, I can call this x also. If this is x, I can call this x. And I can also call this x. Now this length from here to here, I'm going to call y. And this length from here to here, I'm going to call that y. Okay? Now if this is y, and this is y, what would this length here in the middle also have to be if it's a rectangle? Y. So I really do not want to have sides of this rectangle in which they're x's and y's. So somehow, some way, I must write all of these so that they only have x's or y's. I'm going to go for x's. So here's what you do. See all this fence that you use? See the fence that goes from here to here to here to here to here to here and down. All that fencing you used was how much? 200 feet. Got it? So, if I take this side plus this side plus this side plus this side, x plus x plus x plus x plus my 3y sides plus y plus y plus y, that's going to equal 200. So I really have 4x plus 3y equals 200. Because 200 is the total amount of feet I used of fencing. Now I want to get y by itself so I can rewrite my y's with something else. So I want to get y by itself. So I'm going to bring the 4x over and make it a negative 4x. Now divide both sides by 3, and you end up with 200 over 3 minus 4/3 x. Now that's, by the way, 200 over 3 minus 4/3 x is the exact same thing as 200 minus 4x all over 3. Trust me, you'll see. We'll get the right answer. So now instead of having y for this side right here, and this side here, and this side here, now I have this right here. I can put that in place of y. So here's what I end up with. Are you ready? Watch carefully. The length of this side here is x, and the length of this side here is x. X plus x is 2x. So my whole length here is 2x. My whole length here is 200 over 3 minus 4/3 x. Okay, exact same thing. Now I like this a lot better than y because it has an x in it. Now I'm ready to solve for x. Now that I have everything written in terms of x, I'm ready to solve for x. Got it? Now watch carefully how I do this. I know the area of this entire huge region from here all the way over to here is 1,400 feet. So I know if I take length times width, it equals area. So I can take length, 2x, times width, 200 over 3 minus 4/3 x. Length times width equals the area, which is 1,400. Here's my length, here's my width, this is my area. Length times width equals area. Okay? And this is 1,400, so the 0 right there. So let's simplify this. 2x times 200 over 3 would give me 400. 2x times 200 over 3 would be 400 x over 3. And then a positive times a negative is negative. 2x times 4/3 x. Well, that's going to give me, let's see, 8x squared over 3. 8x squared over 3 equals 1,400. Now, if any of you did not see where I got these fractions, watch carefully. Put your 2x over 1. 2x times 200, 400x. 1 times 3, 3. Now take this fraction times this fraction over here. This x, 4/3 x, you can really look at that x like it's up here in the numerator if you want to. In other words, 4/3 x is the exact same thing as 4x over 3. Identical, okay? So 2x times 4x, 8x squared, 1 times 3 is 3. So there's my quadratic formula right there, my quadratic equation right there. It looks a little messy, and it is. Believe you me, it's going to be a lot of work. But that is what we're going to use now to solve for x. So stay with me, take really good notes, our last problem, and we're finally finished, okay? Here we go. Now, here's my quadratic equation. I don't like that. I don't like fractions. So I'm going to multiply everything by 3. When I do that, I'm left with 400x minus 8x squared equals 4,200. I multiplied this by 3, this by 3, and this by 3. I multiplied every term by 3. Now, having done that, let's write this. Let's get, well, we know we have a quadratic equation. See, I have a power of 2, and that's the highest power that I have. I also notice I have an x term or a b term, which stings, but that's how it is. So I have negative 8x squared plus 400x. I just swap their place, bring the 4,200 over, make it negative. Negative 4,200 equals 0. Now we can reduce this. 8 goes into all of these numbers, okay? So I'm going to divide everything by 8. Divide by 8, divide by 8, divide by 8, divide by 8. Here I'm left with negative 1x squared. Here I'm left with positive 50x. Here I'm left with a negative And 0 divided by 8 would be 0. So there, finally, after all of this work, I'm finally ready to use my quadratic formula. Alright, and here is my quadratic formula right here. Now, a equals negative 1, b equals 50, and c equals negative 525. Okay? 525 negative. Alright, negative b is 50, so negative 50. Positive negative the square root of b squared. 50 times 50 is 25,000, or 2,500 I mean. Negative 4, and then a times c. Here's your a, here's your c. Negative 1 times negative 525 would be a positive 525. Alright? All over 2a. A is negative 1, so 2 times negative 1 is negative 2. Now next we're going to simplify under our radical. And the number under the radical is called your radicand. Radicand, and your radicand would be 400 all over negative 2. I got 400 because negative 4 times 525 is negative 2100. So 2500 minus 2100 is 400. Okay? Now, the square root of 400 is 20. So I have negative 50 plus minus 20 all over negative 2. Now let's split this up. I have negative 50 plus 20 all over negative 2. And I have negative 50 minus 20 all over negative 2. Well, over here I'm going to get, let's see, negative 30, positive 15. Over here I get negative 70. It'd be a positive 35. So I'm getting out two different answers, okay, which is fine. So there's my two x values. Don't forget that. Those are your x values, okay? That's not your final answer. You're just telling me what x equals. Alright, let's pull this down here. Let's pull this back onto the scene here. And now let's see what happens, okay? First of all, let's use this answer first, okay? Forget this one. Let's use 15 for my answer, okay? Alright, where x is, I'm going to put 15, so there's a 15 here and a 15 here. For my x right here, I'll put a 15, alright? So this whole length right here is how long? 30. 15 plus 15. This length right here, well, 4 times 15 would be 60. So 200 minus 60 would be 140. And 140 divided by 3 would be 43.3 repeating. So the length of this whole line, or that whole side right there, is going to be 43.3. Alright? Did I do that wrong? Let's see. Yeah, it's 12. It would be 40. My bad. 46.3. 3 goes into 140. 46.3. So this length right here would be 46.3. So the question is, what's the dimensions of the corral? Well, the corral would be 30 by 46.3. So 30 by 46.3. Or 46.6. Wow, guys, I'm really sorry, but trust me, I'm not making this up. If you take your calculator and type in 140 divided by 3, you will get 46.6. Okay, I'm not just saying that. So there's one answer right there. 15 by 46 and 2/3. 2/3, same thing as 0.6. Now let's take our other answer, 35, and let's put that in for x. And let's see what we come up with, okay? So I'm going to put a 35 here and a 35 here. 35 plus 35, this whole length from here to here is 70 feet. Now put a 35 right here. So we have 4 times 35, alright? 4 times 35 would be 140. 4 times 35 is 140, so 200 minus 140 is 60. And 60 over 3 is 20. So this whole length right here becomes 20. 200 minus 140, because 4 times 35 is 140, so 200 minus 140 is 60. 60 over 3 is 20. So this whole length here is 70. This whole length here would be 20. So, and you know what? I see now, okay, okay, for their answer they put 15 by 46. So they wanted the dimensions of each corral. I was giving the length of the whole thing. Doesn't matter. I'd give you credit either way. It doesn't matter. So the length of the entire corral would be 70 by 20. Now their answer over here, they have 35 by 20 because they wanted just this corral right here, which is fine. If you told me on a test or a quiz the whole thing was 70 by 20, I'd have no problem with that. Also for this answer here, we put 30 by 46 by 6. They put 15. They wanted just the dimensions of this corral, which is 15 by 46.6. Okay, either way is fine. All right. Okay, guys, that's it. I hope all of this has made sense. If you have any questions, please don't hesitate to call or email.